All right, let's talk about a secret weapon in Python, something that can make your code way faster and a whole lot more responsive, especially when you're chewing through tons of data. We're going to get into the secret life of streaming results with imap.
But first, let's start with a problem. And I bet we've all felt this exact frustration. You kick off a script, and then you just wait. You're staring at an empty screen, knowing in your gut that some of the work must be done, but you can't see a single thing. This is exactly the spot a junior developer named Timothy was in.
So what was causing Timothy's agonizing wait? What was this frustrating bottleneck? Well, as it turns out, it's a super common problem you hit the second you try to get your code running on multiple processors at once.
So here's the deal. Timothy's analyzing a bunch of chess matches, and he's being smart about it. He's using a process pool to fire up all his computer's CPU cores. But here's the catch. His data is a mixed bag. He's got these super fast blitz games that finish in seconds, but they're mixed with these epic marathon games that can take minutes to analyze.
And this gets us right to the heart of the problem. Those fast results are totally stuck behind the slow ones. Imagine the very first task he sends off is one of those long marathon games. Well, his entire program just sits there and waits. All those quick blitz games, they might be done, but their results are trapped in a massive traffic jam, just waiting for that one slow job to finish.
The technical name for this behavior is blocking. But a much better way to think about it is as the perfectionist manager. You know this manager. They won't show you anything until every single task is 100% complete, polished, and perfect. It doesn't matter if 99% of the report is ready to go, you get nothing until that final period is in place.
Thankfully, Timothy's senior colleague, Margaret, she had a much better way of looking at this. She offered up a whole new way to think.
She asks him this one simple question that just changes everything. Instead of waiting for a giant, complete pile of results at the very end, what if you could get them as a continuous stream, one by one, the second they're ready?
And this is her conveyor belt analogy in action. It's just brilliant. Look, you send out your tasks, a fast one, a slow one, but wait. The result for that fast task comes back almost immediately. You can grab it right off the belt and start working with it, all while that slow task is still chugging along in the background. The results just flow to you as they're finished. And the effect is just, wow, it's immediate. Instead of that long, painful wait in front of a dead screen, Timothy now sees results literally popping up as they get done. He's getting real-time feedback, his program suddenly feels responsive, it feels alive. You know, it's a difference between waiting for a package to be delivered sometime next week versus tracking it live on a map.
So, how in the world does this work? What's the magic trick under the hood? Well, it all comes down to a really powerful idea in programming that honestly sounds a little counterintuitive at first.
It's called lazy evaluation. And trust me, this is the good kind of lazy. Unlike our perfectionist manager, who insists on building a giant, complete list of results all at once, imap is lazy. It only goes and gets the next result off the conveyor belt when your code actually asks for it. And this lazy approach has a massive benefit.
And here's why that laziness is so critical, especially for your computer's memory. The old way, the perfectionist map, it tries to build that entire list of results in memory. If you're analyzing a million chess games, that means a million-item list. You could easily run out of memory and just crash. But our streamer imap, it just handles one result at a time. It's incredibly light on memory, which means you can process an almost endless amount of data.
Okay, so this is all great, but how do you actually use it? Let's boil this all down into a handy guide you can take with you. Let's look at Margaret's cheat sheet for picking the right strategy.
This table is basically your game plan. Stick with the classic map when you've got a small batch of stuff and you genuinely need the whole list before you can do anything else. Use imap for the big jobs, when you want to see results as they come in, but you still need them to be in their original order. And then you've got imap_unordered. This one is the speed demon. Use this when you need results the absolute second they're done, and you could not care less about what order they show up in.
So let's just hammer home two really crucial points here from Margaret's wisdom. First, that lazy part. That's the key to imap being so memory-friendly and perfect for big data. But second, don't forget that standard imap still respects order. That means if task number 2 in your list is super slow, the results for tasks 3, 4, and 5, even if they're already finished, are going to wait patiently in line behind it.
And now for a real pro tip. What if you have millions of really tiny tasks? Well, sending them over to your processors one by one actually creates a lot of chatter and overhead. So you use the chunk size argument to bundle them up. Think of it like this. It's way more efficient to send your worker a box containing 100 screws to assemble rather than walking over and handing them one screw at a time.
So I want to leave you with this final thought. As you go about your work, think about your own code. Where might you have a perfectionist manager lurking? Some process that's making you wait for absolutely everything to be finished before it gives you anything back. Because now you know exactly how to replace it with a conveyor belt.